Welcome to DevOps Should Marry Graph Databases. Originally, I had called this Enable DevOps Success by Modeling, and somebody said that was a boring title. So I figured I went with something childish. I wanted to say thanks, first off, to the organizers for putting this together. I've helped with a couple of things like this, and it's a lot of work and often thankless, because people mostly complain. If you hear weird stutters, it's because I'm used to cursing a lot, and I think the thing that I agreed to follow said no cursing, so apologies up front. So DevOps, and I think at least two of the talks I've listened to so far make this point. Everybody has a different definition of DevOps, but I want to kind of zero in on, if you're doing DevOps right, what does that look like? And then jump into graph databases. Talk real briefly about the kind of sample application that I wrote to demonstrate some of this. I had started off with one of our work applications and just got out of hand because not so much the techniques that we're going to illustrate, but just the complexity, because we do microservices, and the guy who showed the Netflix and the graphs with like 1 million nodes, it got like that. It's a little bit insane. So then we're going to talk real quickly about CloudFoundry. Going to do some, just show you real quick what that is, how to use it. I love CloudFoundry, and the Kubernetes guy pointed out that they're implementing that, so I'm excited about getting to play with that. Real quick, talk about Rabbitmq. How familiar are people with message queue systems? Everybody kind of use? Okay. Going to talk real quickly about 3 things I wrote. One is minor. CF alert and generator. And these are really just to kind of illustrate the techniques. I'll put the code out there for anybody to use. And then real quickly talk about with graph databases, outliers and centrality, and where that comes into play. So these are the 5 pillars of DevOps success. I can't even remember where I grabbed them from, but I thought it did a good job. I'm sure it was like Gartner or somebody who should know. Well, maybe not Gartner. So the first thing is you hear like CAMs, the culture, the whatever with it. It's reducing the organizational silos, and that is, has everybody read the Phoenix Project? Did you not openly weep when like operations and the developers came together and they like saved the company? So we all want that, right? We want that success story. The second thing is to accept failure as normal. I have to do that because I've destroyed our Rabbitmq system a number of times trying to write my own Rabbitmq like resiliency framework. Implement gradual changes, which is important, especially, I'm sure some of you, I started at the company I'm at now about 9 years ago, and they've gone from kind of a startup mode of just get stuff done to now get stuff done but do it well. And so we're having to sort of go back and implement some changes. And so doing that gradual has been much more successful than evolution over revolution, I guess, is the thing that I hear. Then leverage tooling and automation. If you're running any type of microservice architecture, I think we have about 275 apps. It's impossible to keep in your head. It's impossible to manage without some type of automation and tooling. And then measure everything. And this last one, I really wish I was over there on the Prometheus, because this more and more is getting to be important, especially when you have 275 apps. Just tracking down where there are delays or if a workflow has gone down, measuring everything is important. So real quick, introduction to graph databases. They're super simple, which is why I like them. So we're going to walk through that. All a graph is a set of nodes and the relationships that connect them. There are all kinds of data science reasons you should love them, traversing graphs, things like that. It gets to be, especially when you have huge data sets, it gets to be more efficient than the relational data model. It's basically anything where you have an entity that you want to map and where the relationship between the entities that you've mapped is equally important. So, I mean, basically, anytime you've all probably participated in architectural sessions where you're drawing on the whiteboard, you end up drawing nodes and edges. I mean, it's just, the graph database I use is more an accident of history. The guy who wrote Neo4j went to one of like the first NoSQL conferences in Atlanta, and I went to it, and he was there, and he gave a great talk, and I was like, this makes modeling easy. But there are a ton. I think Amazon at the last, what do they call it, Rewind, Reconnect, whatever it is, announced that they are doing a hosted database solution. I haven't played with it yet, but kind of excited to see. So the type of graphs that we're going to be interested here are known as property graphs. So basically you have a node, and then that node can have a unique identifier, properties, kind of ad hoc properties you just put on whatever properties you want, and it can have a type, which is important for when you're walking through things. The types that we'll be interested in today are apps, queues, topics, things like that. So finally we get to the introduction. I'm Mark Gunnels. This is a cipher statement. Neo4j has its own programming language. If you want to create a node, simply a create. This is just an arbitrary name here, Mark. And then where you have this colon, that's the type. So I'm creating a person, and then I'm assigning properties to it. Name Mark Gunnels, and then I have a Twitter account that I check very infrequently. I should probably put my email up there. Also, I think Twitter's probably going to block me for something I did for this talk. They've already, one of my workers is already suspended, so we'll take a look at that. I work for TRHC. It's Tabula Rasa Healthcare. Like I said, I've been there for 8 or 9 years. It is a fantastic company. They do good work. They work in the medication risk management space for PaaS, which means they basically try and keep doctors from killing elderly people. I probably shouldn't say that while we're being filmed. But it is fantastic, and you get to meet people that you've actually helped and things like that. And the science is interesting. It's a fantastic company. So like I said, I work for them, so we have a relationship. Again, relationships, unlike in kind of relational databases where you do like join tables and then you have to put things, relationships are first-class citizens in graph databases. So again, they have a unique identifier, they have a type, they can have properties on them. And they can also be directed, which is particularly important for the example we're going to model today is kind of message flowing. So it's good to know which way the messages are going. And so here, just another create statement. Match is basically your where clause, sort of. So I'm just matching a person and a company where the person's name is Mark Gunnels and TRHC. I'd be showing you all this on a graph database, but I can't get to it right now, and I'm not quite sure why. And then I just create the relationship here. Again, when you're referencing a node, it's just You put in parentheses when you're referencing a relationship. It's in square brackets, and then you just indicate the directionality here. And I gotta hurry. Thought it's worthwhile to mention, we're hiring for software engineers, platform engineers, quality or insurance engineers, and I gotta move on. And then whenever you're ready to kill a graph, this is basically your truncate table. You just say match all the nodes, detach, eliminates any relationships they have, and then delete the node. Real quick, just for time, why graph databases? Again, there's all kinds of mathematical reasons and performance reasons, but really it comes down to they're just whiteboard ready, right? Like I get up there, draw a model out, things on the whiteboard, and it just is very simple to translate it to a graph database. The other reason is there's so many things to model when you start talking about infrastructure. Today, we're just going to look at essentially apps, again, topics, queues, things like that. But if you're really getting into the weeds, you want to know what build pack was run on this application when you pushed it up. Because you want to know which version of node it's running, because God help you if it's 6.2.1 rather than 8 node developers. Anyway, so the sample microservice we're going to do is we have the tweet receiverator, which basically just uses the Twitter streaming API to grab any tweet that has hashtag Golang. I throw it up onto a exchange. The tweet extractor consumes that message, basically pulls out any URLs and hashtags that are there, throws it back up onto the exchange, and then I had a tweet retweeter, which would go and retweet it because I figured, well, I've extracted some value in this relationship, so I should retweet, which that didn't work out well. And then I changed it to the tweet favoritor, and that didn't work out well either. So sorry, Twitter. So again, there's many pieces of infrastructure. We're going to look at CloudFoundry and Rabbitmq. Again, I threw this up here. There's so many things. This is basically a mapping of a friend's company that also runs the infrastructure on CloudFoundry, and it basically, he didn't understand, like, they had a lot of applications. He didn't know what they were written in, which build packs, things like that, and which services they were mapped to. CloudFoundry has this idea of, is everybody the 12-factor apps, where you have the backing services? That's another reason I love CloudFoundry. I don't have to worry about spinning up a Rabbitmq. It handles that for me, and then also manages security by invalidating credentials and revalidating credentials. It's a nice system, and so again, we're going to limit what we're modeling just for because I have like 15 minutes to go. So the first thing about CloudFoundry is basically you just push your app up. Push your source code up, you can push artifacts up, and through clues for Golang, for instance, it looks to see, are there Go source files? Is there a vendor? It builds it and just runs it. And it's super nice as, from a developer perspective, and I will, no matter how much I sort of cross over into some of the DevOps stuff, whatever that means, I'm always at heart a developer. So I love just being able to push things to, and so we'll push up the tweet, retweeterator, or whatever I ended up naming it. So basically you just say, wow, that's really small. And it's not getting better. Not quite sure why. Basically, all this says is cf push the name of my app. And that's going to be the app name up on CloudFoundry. And I point it to a manifest YML. All a manifest YML is, and I'm about to show some credentials, but they're now invalid, so good luck with that, because Twitter's mad at me. At least get me to the, like, one more presentation to go in and make sure the app is actually dead before you hack me. So all the manifest does is tell, it's one degree or another like the, some of the Docker files that he was showing, Rob. Basically tell it how much memory you want to consume, how many instances, which is always nice to be able to scale up and scale down quickly. You do cf scale -i, number of instances you want, and CloudFoundry just pops them right up. Here's all the things if you want to hack me. And then it's just basically the environment variables I want to run it by. And then I tell it which service that I want to bind it to. This is the name of the Rabbitmq service. So I can't type while I'm up here, apparently. So I push it, gets uploaded to CloudFoundry, and it'll just run it. I ask that you believe me in the interest of time, so I can kind of get through this stuff. So that's cf push. If you want to know stats or anything about your app, the state it's in, you just, we're going to do that. And I'll do, so the receiver rater is what's streaming from Twitter. I just do cf app, and it tells me how many instances running, how many CPU, memory, things like that. The nice thing is the CloudFoundry, Pivotal's done a really good job of, I keep wanting to say cull, but that's not the right thing. It's the opposite of culling. Like encouraging the community. So there's basically every type of exporter you could want. So if New Relic's your target, Datadog, we have an Elk stack that we push all the events to. Basically everything that happens to your app is an event and will get streamed, which we'll leverage in a second. But it'll tell you kind of all the apps, so you can always see the history of your app. So again, if you want to measure everything, pipe this to, and you really should just be over in her talk, the Prometheus, and extract all kinds of fantastic value from. So we're going to go on cf app. You basically can start, stop the app at will, scale, restage the app, which tells it to rebuild. So if you've pushed out new build packs, things like that, you can control the whole infrastructure. This is really nice for instance, we had a huge database migration that was going to take like 10 hours, so couldn't really blue-green it. So I wrote something, basically same kind of techniques here, went out, looked at our entire production, got all the app names, looked at where they were in message flows, and then wrote like cf stop, so I could stop, basically called the app euthanasia. So could euthanize our infrastructure and then had a Lazarus script to bring it back. Yeah, so being able to kind of easily, whenever you kind of push to CloudFoundry, it gives you that, there's no unicorn apps, right? If you want to start an app, it's cf start. You want to stop it, it's cf stop. It's not logging, SSHing into a box and trying to remember whether this is running forever or whatever. It's just cf logs if you want to see the logs of your database. Wrong. Again, it caches these logs if you're if you need to, you can stream this to an elk stack, any of the log systems. We're going to move on. CF services, again, backing services. Okay, Rabbitmq. We're going to go through this really quickly. Rabbitmq implements advanced message queuing protocol, which basically specifies, and this will be the only slide we're going to look at, and I'm going to jump through them because it basically tells you everything you need to know. You push to an exchange, and then you bind queues to the exchange to do routing. So if you need to do pub sub, fan out, Rabbitmq supports it. It also has a really nice HTTP API, much like CloudFoundry. So extracting topology information from Rabbitmq is super easy. Message exchange. The one that we're going to be interested in is a topic. And it lets you route based on a routing key. Top exchange, bindings. This may, even if you're just a DevOps person, I would, like on the operation side, message queues are not used enough these days. This gives, anytime you throw a message queue in and turn your system into asynchronous, it gives you a lot of flexibility on the infrastructure side. But that's a whole other talk. And then when you want to consume from a exchange, you bind a queue to it, and then your application essentially talks to the queue. It just acts as a mailbox for your application. So we're going to real quick revisit those. What we're interested in, after seeing all that, is reduce organizational silos, accept failure as normal, implement gradual changes, leverage tooling and automation, and measure everything. So the first thing is, again, Rabbitmq has a nice HTTP API. And I keep going to the wrong. So we're going to go to this application, Miner. This is written in Go. It's an HTTP API. If you like Ruby, if you like whatever your language of choice is, there's a binding for it, even you Node people. Oh. So for Rabbitmq, just run it. It goes up and basically walks the Rabbitmq topology, and then I just shove out, create, and match statements. This is really easy to write. Like I'll put the code out there, and then you can implement it in whatever you want. And then CloudFoundry is the same way. I thought I... Again, you can walk through the apps. I always like to kick out what language it is, just to kind of keep an eye on where things are. But again, create the node. The properties, I throw in the build pack, things like that. And then looking at the end routing key, out routing key for the different exchanges. It's always super easy because basically you can go, if your developers aren't organized, again, I'm looking at you Node developers, and you name like your routing key, environment variables, whatever, you can always just walk through all the environment variables and go and bounce it up against the Rabbitmq API to see what it matches and what it is. So you can see, again, I create the node for the app, and then I just run a match, and then I create the relationship for whether it's producing or consuming from. CloudFoundry, again, both of them HTTP APIs, REST APIs, so it's easy to mine them. CloudFoundry in particular is a rich API. You can look at services, extract credentials, rewrite environment variables, things like that, which we've, one notable instance, we accidentally invalidated some credentials and real quickly wrote basically using this stuff to go and update all the apps and do like a rolling restart. So this stuff is really handy and also dangerous. Again, euthanized our production infrastructure one time accidentally. So now we have a model of architecture and infrastructure. In my position now, what I do is I'm principal software engineer, product improvement. And I've been at it for about 6 days now, so I'm still figuring out what that means. But so if you've got any ideas, throw them my way. But what so far it's meant is being able to take and kind of create models. This is basically using all the minor stuff. Created a graph representation of our tweet, retweeter, or whatever sample architecture. And so this becomes a useful tool for, our, I think he's called a platform engineer now because DevOps isn't the cool term. I'm not quite sure why, but he comes to me, he's like, well, here you've got, if I had, usually I have a queue that streams every message that basically passes over a topic and then writes it off to a database somewhere, so I can always recreate what happened, because we don't have Kafka, which would be nice. So let's say that was writing to a database. He's like, well, I've got to update that database, or you filled up, which I have, filled up the elk stack. So we need to plan some downtime. Well, I don't want to lose any of the tweets, right? Those are valuable. So we look at this, we say, okay, so this is producing tweets. Here's another producer that also consumes. If I shut this down, then things will just queue up here. And so having conversations like that becomes really easy. So again, harmony and culture and love. But unfortunately, we still have to accept failure as normal. The guy who was talking about Gremlin, and where he's talking about you don't want to be on the phone at 2 a.m. with a VP level guy not knowing what's going on, which I'm 43 at 2 a.m. I have no idea what's going on. So I've been in situations where he's like, well, what does this app feed? What's the implications there? Things like that. Once you've sort of given yourself the context of what's feeding what, if one of these nodes goes away, the implications become, you can automate basically deriving the implications, which is, so what CF alert does is it looks for app crashes from CloudFoundry. Again, CloudFoundry can stream events, so it's getting those events. It's basically asking for all the events, a minute behind. If it sees we're just going to simulate an app crash. I told it instead of looking for an app crash to look for just a stop app. If it looks, then it can walk the graph and tell you what apps are impacted. So you immediately know, and you can alert, for instance, those teams that are running the app. So we've had instances where I run something called the audit stream, which basically takes our main database and streams changes from it onto a Rabbitmq. And there are a whole lot of feeder applications. And if that thing goes down, then walking through all the implications, all the workflows at 2 a.m., you can see here, tweet extractor, service disruption, retweeterator, service disruption, basically all the downstream apps. So you give yourself that automated context, that context you will not have at 2 a.m. after when somebody's on the phone yelling at you like, hundreds of thousands of dollars are being lost every second. So, and then the other thing is, if you grew quickly like we did, and you might be lacking some documentation, being able to derive these things becomes very important. So that's planning for failure. That's not my slides. I don't know why I called this generator Jack. But basically, we had some bad habits when we started. We would go to the Rabbitmq console and define our topologies without, so violating that whole infrastructure as code thing, right? We would do everything manually. So we had to back that up. So again, if you have everything mapped out, that becomes super simple. Generator, yeah, nope. So it can go, and for each app now, basically what we started off doing was when we would identify the apps that didn't declare their topology like they should, and we would go and stick in the curl statements in like a migration directory for them to roll forward and roll back. So you can do a curl, a put, and push the topology onto the Rabbitmq, the target Rabbitmq. You can write a rollback script of an x delete and get rid of all the top changes. And then, so it becomes real easy to do migrations. Whoops. Then there are cases of you want to make a change because you've done something really stupid. I tried to write my own framework to do reconnects to Rabbitmq, all these resiliency things. And one of my apps got an unexpected error. Because it's Go, you can do all these neat concurrency things. And basically, I consumed all the connections of our Rabbitmq, at which point I realized I'm not a bright man for a number of reasons. And so I just went out and found a really good package, but I didn't want to have to go and write all the code by hand because, again, there's something like 235 services. So I just generate. And to show that I'm not a bright man, I tried again. The whole reason I did the Coney was I was, again, bad name, Watership Down, trying to write my own resiliency framework, and it wasn't working. So I wrote this to just go and generate the Coney code for me. So what this does, though, is it lets you kind of step changes in. We had apps that were not declaring their topology because we had modeled our application and their interactions with Rabbitmq. First, we could do kind of the migration script thing of all the curls and the puts. And then when we had found a framework that we really liked, because we had modeled everything out, we can just generate our code. And then, because you can program GitLab as well, you can just go and inject this code that you've kicked out. So when you're, again, dealing with 235 apps, you've got to have this kind of tooling. Generate coding. Again, I'll just run this real quick. We grew really fast, and we had to shift from getting things done to getting things done well. We have all of these kind of legacy tech debt. So if you have GitLab, and I know there are similar things for GitHub, if you've modeled everything out, like you can do sequence diagrams. This basically models out all the interactions as a graph, and I can just go and drop this code in at GitLab, and it will basically just display the graph. So I can create the code. I'm working on one to do sequence diagrams for message passing, things like that. So real quick, this book is fantastic. Your Code is a Crime Scene. Basically, the same way that we're kind of mining CloudFoundry and Rabbitmq, this looks at mining Git and identifying areas where you're probably having problematic code, and it tends to be, he kind of compares it to forensic analysis, so he goes into like Jack the Ripper, things like that. It's really interesting. when you've modeled out your applications and their interactions with services, it's real easy to spot outliers. So you just go run some, just basic statistics things and look for applications that are kind of standouts. I have an application, poorly named Certer, that I just threw a whole bunch of stuff in. And it interacts across workflows, totally breaks the whole point of independent deployability for microservices. Every time I run something like this, it just shows like a beacon. But this is useful because it helps you prioritize things, right? So you can't fix everything. At least you can't fix everything quickly. So this helps identify those apps that are a pain. Never mind, we don't have time. The other thing about modeling everything out as a graph is there's all kinds of applicable graph algorithms. The one that I really like is centrality, which will tell you basically in your workflows, those apps that are critical path, where the flow of information basically depends on them. So you can see which exchanges, so if you're doing monitoring, you know which exchanges and queues to prioritize. You know, if you're going to put monitoring in, it tells you which apps you should start with. It's just a way of being able to interact and model things smartly. And it's useful information not only for the developers, but also for your infrastructure people, et cetera. And Q&A, but they told me if you have any questions and answers, meet me outside. So hopefully, sorry we sprinted through that and we didn't quite get into everything. But thank you guys.